Good morning. Today we are continuing to solve inequalities, but today we are doing multi-step, more than just one or two steps. Before we get started, a couple things to remember. If we have an L, that means it is less than, and the other direction would be greater than. Both of these would be open circles because there's no equal to, but if they have the equal to, that means those are closed circles. And again, less than would be pointing to the left, greater than would be pointing to the right. Same thing over here with the closed circle. Less than would be to the left, and greater than would be pointing to the right. One last thing before we start is that if you multiply or divide by a negative number, you have to flip your inequality sign. So it would flip from less than to greater than, or vice versa. So let's solve. We're going to solve this like a regular equation, so draw your line down wherever this symbol is. And we want to do the letter last, so first get rid of your addition or subtraction. Reminder, this is just doing the order of operations backwards. Get rid of addition or subtraction first, then multiplication and division. Our sign did not change, and 8 plus 7 is 15. Then these are touching, that means multiply. The opposite of multiply is divide. So we have x is less than 15 divided by 3 is 5. And we do need to graph it. It says solve and then graph your solution. So on our number line, we have a 5, and put at least one or two other numbers on there as well, 5, 6, 7. This one does not have the line underneath, so this is an open circle. And less than 5 would be like 4 or 3. We're pointing to the left. And you could put an arrow here to show that it's pointing to the left as well. Solving this next one, same thing. I'm going to distribute this first. Negative 0.6 times x is negative 0.6x. Negative 0.6 times negative 5. I know that's going to make a positive because a negative times a negative makes a positive. 5 times 0.6 would give me 3. Well, that's a nice number. And then less than or equal to 15. So I'm going to draw my line down to continue to solve. Get rid of just your addition or subtraction first. I'm going to subtract 3. Reminder, whatever you do to one side, you have to do to the other. And then 15 minus 3 should give me 12. And now this is where you have to be careful. This is multiply, the opposite is divide. Well, if we're dividing by a negative number, reminder up here, if you multiply or divide by a negative, your sign has to flip. So we're going to flip it the other direction. Those eliminate. And 12 divided by a negative 0.6 should give me a negative 20. If you think about it, that makes sense because how many times is 0.6 going to 12? Well, it's going to be more than 12 because 0.6 is less than 1. So there's our answer, and we need to graph this on a number line. 0 would be over here towards a positive, so we'd go down negative 19 towards 0. Negative 21 would be further away. And then this one has the equal to, so this is a closed circle. And it's not less than, it's greater than. Towards the positives would be greater. Or pointing to the right if you put your arrow in there. Let's try a couple more multi-step equations before we add one extra little piece. And this one is a little bit different because we have a's on both sides. It doesn't really matter which one you move, but I like to move the one that's more negative so we end up with a positive number. So I'm going to move this to the other side by adding 11a. So those are gone. We have a 10 left over here. Negative 4 plus 11 should give me a positive 7a. And then a minus 4. Now we have all the letters together. We need to get the a all by itself, doing the order of operations backwards. Get rid of addition or subtraction. So I'm going to add 4. Gives me 14 and 7a. And then last, get rid of multiplication and division. We're going to divide by 7. So we have 2 is greater than a. Well, one thing I did here is I moved the a's to the right side. If I had moved the a's to the left side, that's fine because we want the a's on the left side, but we would have had to divide by a negative. So either way, you're going to have to rewrite this because we want the letter on the left. We got to flip these around so that we can actually graph it. And if we flip that, we also have to flip our sign as well. So we call that rewriting it. We rewrote it so that we can graph it. 2, so 1, 2, 3. And this one is an open circle, because there's no equal to. And then less than 2, like an L, less than, because we flipped it. Less than would be like 1 to the left. I would like you to try this one on your own, and then click play to see if you got it right. Alright, move this 2x over to the other side, because we want both the x's together. If you wanted to move this 6, that's fine. I'm going to subtract the 2, because it's a smaller number. 6 minus 2 is 4, so we have 4x. And then 17 on the other side. We have all the x's together, so get rid of addition and subtraction first. Add 7. 7 plus 7 is 14, so we have a total of 24. And then the opposite of multiplying is divide by 4. And we get x is greater than, because it's not an L, it's greater than 24 divided by 4, which is 6. So on a number line, we're going to put 6 in the middle. 5, 6, 7. This is an open circle because there's no less than, or there's no equal to. And then this is greater than 6. Numbers that are greater than 6 would be like 7, 8, 9. So these ones all turned out to be nice numbers where we have a letter is less than or greater than a number. But now we're going to have a couple other options or possible solutions. First one is the one thing that we've already talked about. One solution, x is going to be less than 7. For example, on your number line, there's 7. Less than 7 would be an open circle pointing to the left. That's one answer because it's everything less than 7. But we also have a couple other options. The first one, if I read this as 5 is less than 2. Yes, that is true. That works. 5 is always going to be, I'm sorry, not less than. It's not an L. This was less than. This is greater than. 5 is greater than 2. That's true. 5 is always going to be greater than 2. No matter what you do, it's always going to happen. So this is what we call all real numbers. And we've talked about this a little bit before. All real numbers is the symbol that R that has 2 lines. So if you were to graph this, it doesn't matter what you put on your number line. If you want to put 2 and 5 over here, that's fine. It doesn't matter. All of our answers are going to be true. So it's really our whole graph. So if we get an answer that's all real numbers, we don't show that on the graph. We just write all real numbers because you can't really graph it because it's the whole graph. And I'll explain what that means when we solve an equation in a minute. And then our last answer, if you solve a problem and you get 2 is greater than 5, well, 2 is never going to be greater than 5. That's not possible. So we say that is no solution. On a graph, there would be nothing actually on the graph in terms of shading left or right or circles open, closed. You can't do it. There's no answer. 2 is never going to be greater than 5. I can't graph that. Okay? So these are our 3 options. You would either write there's one solution, your solution is all real numbers, or that there's no solution. So first, solve this if possible, because some might be possible, like one solution or all real numbers, and some might be not possible, no solution. And this is what I meant by the graphs. A graph with all real numbers is shown highlighting both ways, but with no solution, there's nothing even graphed on it. So let's solve this. First, I'm going to distribute to get rid of the parentheses. 7 times 2 is 14, and there's an x. And then 7 times negative 3 is negative 21. And then we want to get all the x's on the same side. Always move your x's first. Get your letters together before you start moving those numbers around. Once you have all the letters together, then mess around with those numbers. So I have a 14x here and here. I'm going to subtract this one over to the other side. So those are gone. We have 5 is less than, those are gone, negative 21. Let's think about this. Oops. If you looked at your number line, here's 5, negative 21 would be over here. Is 5, like an L, less than negative 21? Well, no, if I have $5, that's greater than owing someone $21. So this one would actually be an answer that is no solution. Because we can't do it. 5 is never going to be less than negative 21. So let's try another one. Draw your line down. I'm going to distribute here as well. 6 times 2x is not 6. 6 times 2 is 12x. 6 times negative 1 is negative 6. Nothing changed over here. And we want all the x's on the same side again. Always move the x's, all your letters together. I'm going to subtract 12. Well, they both eliminate. So we have negative 1 is greater than or equal to negative 6. Let's look at our number line if you're not sure. If this is 0, negative 1 would be here, and negative 6 would be way over to the left. Is negative 1 greater, because it's not less than, greater than or equal to negative 6? Is this greater? And you know what? With these negatives, it's confusing. But yes, that is true. So if you have a true statement, T-R-U-E, your answer is all real numbers. Because no matter what I plug in for x up here, the number on this side is always going to be greater than the number on this side. And if you're not sure, try it out. You can plug in a 1. 12 times 1 is 12. 12 minus 1 is 11. On this side, if I plug in a 1, 2 times 1 is 1. I'm sorry, 2 times 1 is 2. 2 minus 1 is 1. 6 times 1 would be 6. 11 would be greater than or equal to 6. What my point is that no matter what number you plug in, it's always going to be all real numbers. It's going to work. It's going to be true. Here I got negative 1 is greater than negative 6. Here I got 11 is greater than or equal to 6. So if you're not sure once you solve it, plug in a number and see if it works or not. So we can't really graph this. This is your answer. Alright, here's one big problem, only one on this page. On the left side over here, if I want to just focus on this half first, I can combine some like terms, 4m and negative 2m. 4 minus 2 would give me 2m and a 14. And then on the other side, I can distribute. 2 times m is 2m, 2 times 7 is 14. And my symbol in between. So I'm going to move my 2m over to the other side. I'm going to subtract it. So 2 minus 2 is 0, so those eliminate. We have 14 is less than or equal to 14. If you think about this one, the less than wouldn't make sense. 14 is less than 14, no. But what about equal to? Is 14 equal to 14? That answer is yes, so your answer is true, all real numbers. Doesn't matter what you plug in, they're going to be equal on both sides. So this would be a graph that looks like this. It's shaded on both ways. You don't actually have to graph that. I need to see just this answer. Alright, here's a couple problems. It says, write and solve an inequality to find the possible values of x. Here's a triangle, and it says the area has to be less than or equal to 100 centimeters. So a triangle can't be too big, it needs to be small enough so that it's less than or equal to 100 centimeters. So I'm going to start writing the total, all the sides, the area, has to be less than or equal to 100 centimeters. So I'm just going to write less than or equal to 100. I don't need to include my units when I solve a problem. And then the formula for an area of a triangle is base times height divided by 2, or 1/2 base times height. So I'm going to say, you know what, I don't need my centimeters. My base is x minus 2 times my height, which is 10, and then divide it all by 2. To get rid of this division, the opposite of division would be multiplying. I can multiply by 2 on both sides to get rid of that. And then I have x minus 2 times 10. 100 times 2 is 200. And then I don't want these parentheses here, so I'm going to distribute. If I distributed first, that's fine. And so we have 10 times x is 10x. 10 times negative 2 is negative 20. And we want to get x by itself. Now that all the x's are together, we can add 20. So we have 10x is less than or equal to 220. And then divide by 10. We get x is less than or equal to, well, 220 divided by 10 should give us 22. So our answer is x has to be less than or equal to 22 in order for this triangle to have an area that's less than or equal to 100. So here's our answer. We're going to do the same thing down here. This time the area of the square has to be greater than 100 feet. Well, area of a square is just base times height. So the base is x plus 3 times our height. I'm going to put the height on this side. It doesn't matter if the height is in front or behind the parentheses. Don't need units on when I solve, but I do need it on the end. I could put back up here centimeters if I wanted to. Oops. So I'm going to distribute first. 4 times x is 4x. 4 times 3 is 12. And then get x all by itself, so subtract 12. We have 4x is greater than 100 minus 12. Well, 100 minus 10 would be 90. And then minus 2 more would be 88. And then last, divide by 4. 88 divided by 4, I'm going to plug that in my calculator. Some of you can do that in your heads. Should give us 22. So x has to be greater than 22. And our units back on the end there, we're talking about feet. So if this was a wall and you were going to paint a mural, that has to be greater than 100 square feet. Maybe you're painting the side of a building. You need to know, well, this has to be so big. My boss told me this painting has to be really big. I need to know that the whole bottom, x has to be greater than 22. Well, plus 3 would be, this has to be 25 feet wide and 4 feet tall. Maybe it's a big billboard. I don't know. So here's your homework. Make sure you show me your notes before I give you your homework to make sure that you know what you're doing. Good luck.